Okay, thank you everybody for coming. It's a lot of people. I like that. I'm Brujo, as he said. I'm an Argentinian. I've been a programmer for most of my life, but I started working, like being paid to code 15 years ago. And 7 years ago, I met Erlang, and as well, I met the open source community. My previous employment was in .NET, C#, and it was not really open source. But once I get to Erlang, I started to know the community and the ways to contribute and stuff like that. And for the last year, that's all the code I wrote, because being a CTO puts me away from it. But the compromise is that now that I don't need to code for production products, I can do stuff, open source stuff, all the time, anytime I want. And in particular, Gadget, which is the tool I will show you today, is very, very focused on that as well. So it's one of the things I did in that time. I work at Inaka, which we are a company that started in 2010. And the last year, we joined the family of Erlang solutions. Most of us are in Argentina. We have an office there. We usually build applications for Android and iOS devices with Erlang backends and most likely a Ruby on Rails administrative tool. And the characteristic for those applications is that they are highly concurrent and they have millions of users. And those of them, and then two of them are Whisper and TigerText. They are the better examples for that. And along the lines, while working on that, we focus on releasing every small piece that we think we can share with the community as an open source project. We have a long list of those. I will give you a link to a page where we have all of them at the end of this presentation. And today, I'm going to talk about the tool that will help you work, especially in open source projects, and help you keep them in a good shape and well written with quality and checked and stuff like that. But I want to show you first the motivation that led me to create this tool. And it all boils down to one simple question. How good is your code? That was the question when we started working on this. But it's, I take everything, everybody here is a programmer. And we work like writing code. We get it to work. We usually do tests. So we create code that solves the problems that were presented beforehand. But the question here goes a little bit deeper than that. Something that we found particularly important for open source projects is that your code not only works, but it's also good in terms of quality, of maintainability, of performance, etc. So I will separate this question in 4 more specific ones, each one of them associated with a tool that helps you achieve that goal. So the first question is the most funny one. I bet everybody has written code here. Do your code compile?
Second time,
yeah. The question is a little bit more relevant if you say it does your code compile without warnings? When you run make or RLC or rebar compile, do you get a list of warnings when you're compiling? If you call work, do you get a list of things that say, warning, you have this function that's not used or whatever? If you do so, I would say there is something that you need to check there. Because the compilers that the Erlang compiler produces are very few and very specific. And those things, there are things that you need to check to make your code better, even if it's serving its purpose. And there is an option in the compiler that will treat warnings as errors. It was a bit of a discussion with Erlang MK people a while ago if that should be turned on by default, as in Erlang MK is. I am on the turn it on by default team, because I like my program to compile and to not emit any message that I need to fix anything. And also the question is, if your code compiles and you don't see any warnings on the console, are you checking every possible warning? Because the Erlang compiler has many of them. And for instance, my experience with rebar or compiling things manually is that not all of them are turned on by default. You have to add them on the rebar config file or on your console or your emake file, whatever. So I would say that good code is code that, when compiled, produces no warnings. But I will move forward a little bit. Another thing that you can check, because Erlang is a dynamic typed language, you can write code that actually compiles with no warnings, but you can be calling functions that are not even there. And Erlang provides a tool to detect such things, like calling undefined functions or deprecated functions or exporting functions that are not used anywhere. And that tool is xref. And the question here is, oh, it's not moving. Yeah. Have you checked your code with xref? Do you do that regularly? If you don't have a special tool to do it, and you want to do it manually, you will be faced with stuff like this. To run xref as OTP provides it, you first have to, You first have to start the process with a name. Then you have to add the library path, which is usually code get path, the file, the libraries in your current virtual machine. But sometimes you have dependencies and other stuff that you have to add, and you have to add it by doing that. Then you have to tell xref what things it should check, or where are the bin files that it should check, usually on the ebin folder. But if you have a node structure with apps, with different apps, each one with its ebin folder, you have to do that one by one. Then you get to the point where you can run an analysis, but you have to run each kind of analysis by itself, like one at a time. In this case, we're running an undefined function calls check to find functions that we are calling, but they don't really exist. Xref provides 6 different checks. They are not so many, but 6 lines of code instead of 1. It's a number. And then you stop the process, and you get to deal with the results. And the results look like this: tuples with 1 or 2 tuples. If the problem lies within just one function, you will get one module functionality tuple. If your problem is like the undefined function calls, where in a function you're calling another one that doesn't exist, you get a 2-element tuple with 2 module functionality descriptions. It basically says that the function bad with 0 arguments in my module 2 is calling function 4, my function 4 in the same module, and my function 4 doesn't exist. Very tedious, right? Thank God, people in rebar created rebar xref, which is both a command for the command line and also a module where you can run xref and just check everything and get results in this way, where not only the warning is explained, but also you get a module name, a file name, and a line number where you can see the problem. Very, very helpful. But I use Erlang MK. I don't use rebar, or not always. And I won't make xref, but it's not there yet. We submitted a pull request to Loic a while ago. I encourage you all to +1 it so it boils up, and it's merged, and we can make xref with Erlang MK. To add that functionality, what we do was to create xref runner. Xref runner is basically some sort of rebar xref, very, very similar. It runs almost the same thing, but instead of printing out the results on the console, it returns the results of the check in map format. where it tells you which one was the check, where the problem is in file name, line number, and the tuples from xref, the same ones as results from xref during xref directly. So after that, you get to a point where your code compiles, no warnings, no calls to unexisting functions, stuff like that. But what about calls to existing functions with wrong types? And I think, let me know if it's not true, but I think everybody here knows dialyzer, right? And dialyzer is one of those things that, in my experience, everybody likes. Yeah, dialyzer is cool, it's excellent. Do you run it? No. So, and I train a lot of people at Inaka, or some people at Inaka, and every time I get to them, like, yeah, you have to run dialyzer on your code regularly. It's great, it gives you excellent results. I hear two complaints. The first one is I can prepare myself a whole jar of coffee before dialyzer gives me the first warning. So that's kind of bad for development purposes, but it's not true anymore. Since I think the last 2 releases or 3 releases of Erlang, dialyzer got way faster. And if you don't know it, dialyzer has basically 2 steps. The first one is to create a PLT that you have to do just once. It's a file where all the data for everything that's not exactly your application is stored. And that takes a while, but in a project that took like 20 minutes, now it takes like 5 minutes, 4 minutes. Especially open source projects are usually smaller than other ones, than big production ones. So it's kind of fast. And after that point, every time you run dialyzer, it uses that file, and it takes like 5 seconds. It's even faster than running your test suite. So running dialyzer, not running dialyzer because it's slow, it's kind of not a complaint anymore, right? But this is an actual complaint. And this I had to face it myself. Checking the dialyzer produces a lot of warnings. And understanding what those warnings are, yeah, it's usually not that easy, right? Because who among you has faced those kind of warnings? Yeah, I see. Yeah, same happened to me. I can totally relate to that. Because let's take the first one, right? This function has no local returns, says dialyzer. And that's awesome when the function throws an exception, right? You have a function that the only thing that it does throws an exception, clearly has no local return. Excellent, I see it. I see what you mean, dialyzer. But what if I saw that error for functions that don't even have a throw word in it. And the problem was a different thing. It was somewhere else. It was related to the way the function is called, et cetera, et cetera. Same goes for the second one. But what I want to say here is that about that second item, the second complaint, is that once you run dialyzer constantly, it only will be affected by the changes between the last time you ran dialyzer and the new one. So if you have to find the bug or the problem that the dialyzer is reporting, even if the warning is not clear, it can be anywhere. It will be in the things that you changed recently. That should not be that many. And that makes it easier. And about the first complaint, imagine for a second if those 5 minutes it takes to build a PLT and everything that happens there happens somewhere where you don't have to take care of it. It's done for you. Keep that in mind. I will go back to it in a couple of minutes. And now think of your code as a very, very good code. It compiles, no warnings, no undefined function calls, no deprecated calls, no running with the wrong types. Dialyzer is happy, xref is happy, compiler is happy. Are your colleagues happy? That's the next question, right? Once you have your code completely accepted by the tools that comes with OTP, the question now is, can you share it? Will you show your code to somebody else, and will that other people understand it? Will you understand it 5 years from now, 5 months from now, days maybe? And to do that, the thing that usually comes along in other languages is a linter. Or for instance, Ruby, you have Rubacop or HoundCI, stuff that checks your code to see if it matches the rules, not the rules on how to make it work, but the rules on how to write the code. And when I was preparing this presentation, I was doing my research on the available tools, because I will show you a tool that we created, but I want to tell you that we are not the only ones working on that. I found these two, but EarlTidy, I really don't know how to use it, and Tidier is down. It was a website, and it's down for like 2 years now. So they don't really exist. So we created, last year, we created Elvis. Elvis is basically the same thing that other languages have, where you write the rules that you want to check on your source code, and it basically tells you where you are not complying to them. And to run Elvis, you can do Elvis rock after you have compiled it, of course. Or if you use Erlang MK, it's already a plugin. You just have to do make Elvis. It will go over your source code, and it will give you it will produce an output like this one. It will check every file, and if there is a line or a part of your code that is failing to comply to one rule, it will print a warning like that one, specifying the file, the line, the rule that was not followed, and showing some contextual information. You can run it even as a pre-commit hook for Git, so it will prevent you from creating commits with code that doesn't follow all the rules. And now you have a very, very good code. You created your library, you put it up on whatever, you share it with Erlang Questions mailing list, and people will like to contribute to it. And it's like your child, right? You're going to keep it clean and good and with good quality. And now it's not entirely up to you anymore, because if there are other people contributing, you have to make sure that they follow the same rules that you follow. The first thing, of course, is to put your code somewhere where you have version control, so the other people cannot actually alter your code in unpredictable ways. But that's something that everybody knows here. I won't go into detail. Most of the open source projects in Erlang use GitHub for that, which is the same thing that we use at Inaka, so same thing. And GitHub comes with pull requests. And pull requests lets you do something that will help a lot in keeping your code clean. Code reviews. Code reviews allows you to check what other people want to add or update in your code before actually merging it in your code base, which is awesome because you will be able to detect weird stuff about to explode. But it's not 100% awesome, because in pull requests or with your naked eyes, you cannot run dialyzer, you cannot compile it or run xref on it. And what you can do is, of course, go to your computer, clone it, clone the repo, or if you already have cloned it, OK, fetch the changes, check out the branch where the modifications are, run dialyzer, run compiler, run xref, elvis, all that stuff. And OK, GitHub comes with inline comments on pull requests. So you have the warnings with the lines. You open up the pull request page. You go to the line because you want to help the other developer, not just write, hey, dialyzer is bad. You want to, OK, this is the problem. So you go to the line, press the button, write the comment, which is almost the same thing that's in your console, and wait for the developer to fix it. OK, now the developer fixed it. You have to do that again, because he could have introduced a different bug. And that's, I don't know anybody who goes through that process, and I don't think it's a very healthy thing to do. And that's why I created Gadget. Gadget, yeah.
Why don't you just have Travis run Travis?
Yeah, something like that. I will go in that. In fact, I will answer that at the end of my presentation. OK, so Gadget is basically a service. It's in Gadget in akalabs.com, and it's tied with GitHub. So you sign up with your GitHub account. You authorize the application. As you can see, it's only for public repos and only Redux it. It won't change your code at all. And then you meet this screen where you have a grid. The columns are the tools that you can run. The rows are your repositories. You can turn individual tools on and off for each one of them. Once a tool is turned on, for every pull request that you get, Gadget will run the tool and start adding comments like this one. This is a particularly funny example because it's something that everybody complains about, like compiler, xref, dialyzer. Only Elvis is happy with that line because it's a local function that's not used. So nobody wants that here. And Gadget will go, since the tools are running run individually and in parallel, it will produce all the warnings, right? It will run one warning per tool. But that will not require you to run it manually. Like it will go, like it will automatically run the tools, and you can wait until whoever is creating the pull request has fixed all of those things. And what tools do we have? The first one, of course, the compiler. The compiler works with either a makefile or a rebar config file. If you have a makefile on your project, it will just run make. If not, and you have a rebar.config file, it will run a rebar get-deps compile. And it will collect the warnings from the console, and those are the ones that are written in the comments. Then you have xref. Xref runs with xref runner, and it will look up for an xref config file in your repository. If you have that, it will use it. If not, it will run the default set of checks, collect the warnings, and create them as comments. Then you have dialyzer. For the version that's currently on the website, dialyzer only works with Erlang MK because running dialyzer is tricky, and there are many parameters that you have to configure for your repository. For instance, the dependency, where the dependencies are, what libraries are you using, what applications do you want to dialyze, etc., etc. And so, since all of that is already solved in Erlang MK, we just used it. But we are working on doing the same thing for rebar compiled projects and for any project eventually. And the last thing is Elvis. Elvis is just a pass-through because Elvis is already a service that writes commands. So it just goes through Gadget to Elvis and back again. And it uses the Elvis config file, the same thing that Elvis already does. After that, Gadget has a lot of comments it has to write on GitHub, and to do that, it uses another open source project that we created, Erlang GitHub, which started as a very simple SDK where you can just run commands that are translated to HTTP requests to the GitHub API. But we found several things that are more complicated than it looks. For instance, Gadget wanted to write a lot of comments at the same time, and GitHub is not willing to accept such, I don't know, blast of comments, so it rate limits us. And we implemented an exponential backoff inside Erlang GitHub, so if you want to write the comment will be written eventually. And it also provides you with a behavior called a GitHub webhook, which is basically the core of Gadget. So if you want to integrate anything you want with GitHub and listen to pull requests and write commands and all that stuff, you have to just implement the GitHub webhook behavior, which will create a cowboy handler. You add it to your cowboy server, and boom, working. Again, I encourage you to check that on GitHub. I'm not that proud of its documentation, but it's growing steadily. And yeah, it's open for contributions because we didn't implement the whole GitHub API yet. So if you need something, feel free to send a pull request. And in the future, okay, these are future tools that we can add. For instance, we can add ltidy if I get to understand exactly how. If tidier goes up back again at some point, and I get in touch with Costis, maybe we can add tidier as well to Gadget. And if you can think of other tools that we should add to the list, please send me feedback, and I will check them out. And my last comment is that Gadget works only for open source projects. In fact, only for public GitHub repos. And that's not because I'm very religious about it or whatever. It's just that I don't want to deal with, remember, Gadget has to download the code, right? And to compile, maybe you have other libraries that are also private. And so you have to give Gadget access to everything to be able to compile. I don't want to deal with that. I don't want to have your private code on my server and then be like, what happens if something goes wrong and it stays there? I don't want any of that. So it's just for open source projects, for public GitHub repos. You can find Gadget on its website, gadgetinagaLabs.com. You can find all of our open source projects at Inaga GitHub.io. That's our web page, InagaNet, and we write many things in our blog. Some of them Erlang bound, some other languages as well. I am El Brujo everywhere. GitHub, Skype, Twitter, Facebook, and every other application that goes around. I grabbed the names just so nobody else took it. And that's it. Thank you very much. So, Travis, yeah, I have no much experience with that. And when turning Elvis into Gadget was extremely simple. So I just took the opportunity and I used it.
Because Travis will run your build script, your build test scripts on pull requests. Excuse me, my voice is terrible on pull requests. And I have written my standard Travis YML will run dialyzer. I haven't used xref for elvis. I want to check out elvis actually. On it, but I don't see why it wouldn't work.
And do you get the dialyzer warnings and you add that as inline comments in the pull request?
It will tell you. It gives you a little indicator that this Travis says you shouldn't merge.
Oh, okay. Yeah. I don't know. Maybe it's complementary. I don't know.
Yeah, it could be. The other thing this could do that would be very helpful is if it ran, you could run your unit.
We have a huge discussion about that. Yeah. Yeah, but at least for our projects, I don't know. That's a whole other discussion. But part of the thing is that the way we use the unit tests, because they are not exactly unit tests, that's the point. But when you do make tests in many of our libraries, that thing will try to, for instance, we have a library for the Twitter API. That will try to connect to Twitter and in the test. So that's a problem if you have that on a server. If your tests are doing stuff that will not be very properly contained to be run in a server, it kind of gets messy. So yeah, it can be added, but it will have, if it's added, it will have a huge warning like this will be run in a server contained, right?
We have lots of time for questions.
Yeah. Shut. Yeah, over there.
Can you repeat one more time how do you guys use, or what do you guys use the exponential backup for? And also what implementation or algorithm you guys are following?
Okay. The story goes like this. Gadget, we tested the Gadget with a specific repo where we introduced tons of problems at the same time. And so the Gadget server has one user, Gadget, in GitHub, and he wants to write the comments for all those warnings at once, or very, very close one to another. And that hit a rate limit imposed by GitHub. But that rate limit is unknown. GitHub won't tell you what's the number of requests you can do. It just stops you from doing it. It starts responding with a 403, and you deal with it. So what we're doing is, well, dealing with it. We have a queue of requests. If we had a 403, we wait. We don't know how much we have to wait, so we wait 100 seconds. Then we wait 100 milliseconds. Then we wait 200 milliseconds, 400 milliseconds, etc., etc. And the way to implement that is ad hoc. It's written there. It's a list of numbers, and it uses gen server timeout. So it just waits for the next until it gets to GitHub, and it resets the list again. Basically that. Yeah.
Has anyone hosted Gadget themselves for use with a private repo?
No, because Gadget code is private. But if you want your own Gadget-like thing, you can do it. Erlang GitHub, you start the Cowboy server, you add a GitHub webhook, and you run dialyzer, you run xref runner, it's open source, elvis is open source, dialyzer, of course, comes with OTP, the compiler as well. I tell you, it's one module with a couple of lines of code, but nothing else like that. It's just very, very simple. It's everything open source except for the project itself.